Nanoscientists studying the very small can help explain macroscopic phenomena. Professor Jacqueline Krim is one of several NC State physicists involved in nanoscience research.
Nanoscience helps us understand the atomic scale origins of friction. Nanotribology is the study of how friction originates at the atomic scale. So the atomic scale is on the nanometer or smaller. And we study the fundamental origins of the mechanisms for friction dissipation. We connect that with the macroscopic scale, mesoscale, and atomic scale level friction for different systems. The vast majority of solids are incommensurate with each other when they're in sliding contact. This is easily demonstrated with a comb. You can do this at home. You take two combs, rub them together, and if they have exactly the same spacing, you'll feel much larger friction. Whereas if you take combs that have different spacing, you'll feel the friction is much lower. And this goes on at the atomic scale as well. If the atoms have different spacing, the friction plummets by orders of magnitude. One of the areas where we see very strong differences between macroscopic and nanoscale phenomena is in the difference between liquid and solid friction. For example, we typically think of water as being slippery. However, if I apply a thin film of water and put a small piece of paper, the friction increases. We know that if you take a book and lick your finger to turn the page, the friction is increased. Buckyballs, or carbon-60, are one of the ultimate nanoscale objects. They're soccer balls that are about 10 nanometers across, and we study their properties on surfaces. We've studied whether the buckyballs, when they're spinning and rolling, can make a surface slippery. The answer is no. Believe it or not, the thermal motion makes them rotate in many different directions, and it's more like walking across a gymnasium full of rolling basketballs. Buckyballs are marvelous from their electronic property and photovoltaic properties. When they're adsorbed on surfaces or placed on surfaces, we can see all sorts of properties associated with when they're illuminated. And we are currently studying whether the friction changes in a significant manner when the buckyballs are in a dark chamber relative to an illuminated chamber. So the College of Sciences, the College of Engineering, side by side on Centennial campus, has been a tremendous asset to our ability to have colleagues who are very much aligned with the type of work we do, which spans a spectrum of applied to fundamental, all in one case.
Professor Krim is one of several physics department faculty members involved in nanoscience research that helps our students become productive and inventive physicists as members of the NC State Physics Department.